Hello everyone, this is Manacharya and I'm back with another video. So in today's video, I'm talking about GS Case Challenge, which is the first round of GS Campus Beat. Let me explain you what is GS Campus Beats. GS Campus Beats is an annual event of GS Associate in which they conduct webinars, case challenge competitions and interactive sessions. Students from top engineering colleges participate in this event and top performing teams get exciting prizes and an opportunity to be a part of GS Associates. They get the PPI opportunities. So in this video, we'll take up a mock case challenge. Remember, it's a mock case. It's not an actual case of GS. We have developed a mock case that will be actually helpful for you to understand how the entire case study is divided into scenarios, how can you distribute your work within the team, how to approach the problem statement, and also how to make the final report while you submit the same. So in this video, we have Abhinash Pani. He and his team participated in GS Campus Beats last year and emerged as one of the top 150 teams. And he went through further rounds of this Campus Beats program and finally got placed in GS Associates. So in this video, he will actually share his experience and also will actually solve a detailed case study and will say you how how you need to follow up the things in order to complete the case study challenge.
Hello guys, I'm Abhinash Pani and thank you so much for having me here. I am currently in my 4th year in Metallurgical and Materials Engineering at NIT Rourkela. I had participated in GS Campus Challenge, Campus Beats Case Challenge in a team of 5. Our team was named as Adventus and we had secured top 150 rank in India.
Thank you for the brief intro, Abhinash. Now let's start with the case challenge.
Okay guys, let's move on to the case challenge from Campus Beats. This is a solution template so that you guys can become familiar to how to submit your solutions to Campus Beats. First, you have to fill the team details, team name, college name, and your names, including your team details. So let's move on to the problem. So here, Pulse is a soap manufacturing company, and it sells a popular soap called Sinov. Company background is also given that it manufactures and markets only one single soap, Sinov, and it is popular with upper class population. It has a sales team of 200 salespeople to promote it and visit shops and warehouses to influence them to sell Sinov. So here our mission is Mr. Ajay, the Vice President of Pulse Sales and Marketing Function, has approached GS to explore the idea of splitting the sales force into two teams, one for warehouses and one for shops, and has also approached GS to identify the appropriate sales force size for each team, and also asked us to design a monthly report that would help sales people track sales of Sinov. So they have given us three parts of this case challenge to answer their queries. In the first part, they wanted us to determine the optimal sales force size for shops and warehouses. In 1.1, they wanted us to ask how many salespeople should be assigned to promote Sinov to warehouse. And in 1.2, they want us to answer how many salespersons should be assigned to promote Sinov in shops. Here it is also written that it does not have to be 200 reps, as it is written in the company background that they have a sales team of 200 salespeople to promote Sinov. So we have to analyze the data in page 8 to know the best sales force size for warehouse owners. So from this data, we can see that is a table that shows us the number of widgets required in different warehouse categories. There are 5 warehouse categories. One is big money, one is tough ones, smart buys, friendlies, and easies. And we can see the number of warehouses in each category. There are 15 big money, 100 in tough ones, 115 smart buys, 200 in friendlies, and 300 in easies. And the third column is the number of widgets required to maximize products from each warehouse. That is the number of widgets per week we need to convince them to sell in their warehouse. So for big money, we need 4 weeks, 4 widgets per week. And so we have to invest more time in big money and more people in big money. But the return in big money is more because this is the biggest merchant in the warehouse category. They give us the highest profit. So if we give more widgets per week to big money, that is worth getting the profits from big money. So from this, we have to calculate how many widgets do we need per week, but to convince each category first. So for big money, for each category, how do we find that? We have number of warehouses in each category, and the number of widgets per week we need to convince them. The number of visits per week we need to convince the whole warehouse category is because if we multiply these two, 50 into 4, that is 200. Then for tough ones, 100 into 3, that is 300. For smart buys, it is 150 into 2, that is 300. For friendlies, it is 200 into 2, that is 400. And for easies, it is 300 into 1, 300. So, to convince all of the warehouse categories, all five of them, we need around 1500 visits to convince them per week, to convince them to sell Sinov. And we know that a salesperson can make 12 visits per week. So to calculate how many salesperson, the optimum amount of salespersons to be assigned to warehouse category should be 1500 by 12. That is around 125. So we need around 125 salesperson to convince all of the various categories. But here we do not have any constraints. But normally, we are given that we can only spend up to 100 salesperson for various categories. So what do we do here? We have already discussed that big money gives us the highest profit. So we assign more of our salesperson to big money, then tough ones, then smart wise, then friendlies, and leave out some of the easies because they give us the least profit. So this is how we can get to the optimal solution that has been asked for 1.1. Here we see in 1.1 they have asked us to find how many salespersons should be assigned to promote Synapse to warehouses. So from our calculations, around 125 salespersons should be assigned to warehouses to give us to convince all of the warehouse categories to sell Synapse. So let's move on to part 1.2. In part 1.2, they want us to find out how many salespeople should be assigned to promote Synovin shops. For that, we move to page 9. In page 9, we find a graph where it's given visits in a year versus annual sales. And we can see here that for 30,000 visits in a year, they make around 150 lakhs in annual sales. So, for 30,000 visits, they make 150 lakhs in annual sales, and they work for 40 weeks. Each salespeople work for 40 weeks in a year, so they make around 30,000 by 40 visits per week. That must be around 3,000 by 4 visits per week for each salesperson. And we know that salespeople make 15 visits per week. So the optimal number of salespeople that are required to get 150 lakhs in annual sales must be around 3000 by 4 into 15, which is around 50. 50 is the optimal number of salespeople to get 150 lakhs in annual sales for 30,000 visits in a year. And we know that each salespeople cost us around 9,000 per week. So in a year, that must be around 9,000 into 40 because they work 40 weeks in a year and they get 9,000 per week. So for 1 year, they get around 9,000 into 40. That is 3 lakh 60,000. So okay, and then we know that there are 50 salespeople working to get 150 lakhs in annual sales. So the total cost should be around 3 lakh 60,000 into 50. This is around 180 lakhs. So this is the total investment for sending salespeople to visit shops, and we are getting annual sales of 150 lakhs. So we are getting loss in this case. We are getting loss and we are not getting any profits. So we check for each of these cases in 480, 630, 720, 750, and 760 and find out where do we get the maximum profit. We find the investment we are making in salespeople and see cross check it with the annual sales in lakhs and then compare in which case we get the maximum profit. There we can get the optimal number of salespeople we should send to visit shops. Here I have explained the what I have explained before. I have written in the points. For part 1.1, I have already told you the answer that we have to visit the tables, and in table we see that there are warehouse category, number of warehouses in category, and number of visits required. Then we calculate how many visits per week we require for each category to convince them. That is by multiplying these two columns. And then we get the number of visits per week for each category, and then we sum them to get number of visits per week for all of to convince all of the five of various categories. That comes out to 1500, And then we see that a salesperson visits warehouses for 12 times a week. So we get around 125 salespeople. That is the optimal solution to convince all of the warehouses. And then for 1.2, I have also we also follow the same format. We go to the graph and find widgets per week we require to get around 150 lakhs in annual sales. That comes out to 3000 by 4. And then we find out how many optimal salespeople we require to send, optimal number of salespeople we require to consent to the shops to convince them. That comes out to 50. And then we cross check it with the amount of investment we make on salespeople by using this data, which in this case we get a loss. And then we find for all of these cases where we get the maximum profit, that is the optimal number of salesperson we should send to shops to convince them. Now let's move on to part 2. In part 2, they want us to design a report to allow salespeople visiting warehouses to track their performance. So what is this report? They want a report layout that will allow them to track the performance of their salespeople. And these following informations are given. That we do not have the data of warehouses. We only have data from shops. Here we can see we have only have data from shops, and shops buy from warehouses. So shops get their materials from warehouses. So we have sales data given from the shop in the upcoming pages, and we also know that shops, when convinced by salespeople, buy from a warehouse, but and warehouse only sell only to the shops. So this is the connection: warehouse sell to the shops and shops buy from warehouses. And a postal zip can contain only one warehouse. This is very important information, that a postal zip can contain only one warehouse. So from if you go to the next page, we can see that in the table here, the warehouse information, all the warehouse IDs have different postal zips. That is shown in the given information, that there is only one warehouse in the area of a postal zip. So here it is confirmed that each postal zip has a distinct warehouse ID. So there are no same postal zips for different warehouse IDs. But that is not the case for shop ID. Here we can see that postal zip 411013 is similar for shop ID 1 and shop ID 3. So this shows us that here the postal zip is 411013, and also warehouse 1 has 411013. So we can conclude that shop 1 and shop 3, shop ID 1 and shop ID 3 buy their products from warehouse ID 1. Also segments are given, and so we can connect warehouse ID and shop ID using postal zip ID. Here we are considering postal zip ID as our base. Also this table, this is the salesperson's visit data. It is so that which shop ID, in which shop ID, which representative has gone to convince them. Also this is also given for warehouse ID. That for warehouse ID 1, visiting representative ID is 5672. For 2 it is 3076. For 3 1245. So in this way we can see that representative ID is different for shops and different for warehouses. So it may be also possible that for a same shop that buys from warehouses, a single person will not go to convince a shop and a warehouse. Different persons go, different representatives go for a shop and a warehouse that buy from that where one shop buys from that warehouse. Also, if we go to this table shows us the sales. Here we were given in the given that shop, we have the data only about the shop sales. We do not have the data from warehouses, as we can see here. So here in this table we have the sales data, shop wise sales. That is, we have given the shop ID and we have given the sales. We can see in rupees sales of Sinov. So in this table we are going to we are going to give them a table so that they can keep track of their salespeople, how they are selling, convincing the shops and warehouses. So if we see the solution in the next slide, here we can see that what I did, that I connected when I told that I connected postal zip to connect shop ID and warehouse ID. So I did that. I got to know that warehouse ID supplies its materials to shop ID 1 and shop ID 3. So here in the table, what we will do is we will consider representative ID as a base because it is unique for all of them. Repetitive ID is unique for shop ID and it is unique for warehouse ID. As we can also we can see that for a single shop ID to shop ID to different representatives can go to cross check and to convince. Just like they want to convince the shop ID, if one representative fails, other representative can succeed in that shop. So, but we did that. We took repetitive ID one as the base, as the it's the first column. In the second column, we inserted shop ID and calculate the shop ID sales because we have the shop ID sales data. If we put shop ID one, we have the shop ID one data 4,000. We can see the sales of Sinov is 4,000. So here shop ID sales we can calculate 4,000, and with shop ID three the sales we can calculate. Total sales we can calculate from shops for representative ID 1. Same can be done for warehouse ID, but here we know that warehouse ID from postal zip code, postal zip, we can find out which warehouse applies to which shops. So we can it is easy to calculate the sales of each warehouse from the shops to which it distributes. So here we can see if we see that warehouse ID distributes to shop ID 1 and shop ID 2. So it is easy to calculate the sales from warehouse ID 1 by adding the sales of shop ID 1 and shop ID 2. Then we can get the sales from warehouse ID 1. Similarly, if we can see for warehouse ID 2, it applies to only 4, where shop ID 4. So we can calculate the sales from shop ID 4. And then the total sales of warehouses can also be calculated by the sum of these. So it is by here they can keep track of each representative. How many shops did he go to convince them? How many warehouses did he go to convince? And how much sales did he gather? Did he succeed or did he fail? By this, they can easily keep track of their salesperson and how they are succeeding in their jobs. So this was the question that we have to create a report layout that would allow salespeople to track their performance. So by this, we can see how much sales each representative ID has gathered using the sales shops and the warehouse IDs sales. So let's move on to 2.2. Here they wanted us to create a flow chart that would be used to process the files to create the report. We have created the report. We have shown them how to give the table, but we have to explain the flow chart, how the hierarchy works, how we use postal zip code to find which shop ID takes materials from which warehouse ID. So this can be done using a flow chart. In the flow chart, we have written that postal zip is the base. As we have seen before, the 411013, I can show it. Here if you see 411013 postal zip is similar for two shops, and we know that 1 and 3 shop ID collect the materials from warehouse 1, buy the materials from warehouse 1. So in the flow chart, we keep postal zip ID as the base, and from that we know we can find out a shop ID and we can find out a warehouse ID, which can be connected with each other through postal zip code, and we can easily know which shop ID buys materials from which warehouse ID. And we also know that each shop ID has a representative ID and each warehouse ID has another representative ID, because we already know that there can be many representatives for each shop and for each warehouse. So this is the total flow chart, and these are two substrate flow charts. Here we can see that I am explaining that each postal zip has a warehouse ID. That same postal zip can have a shop ID, but they will both have different representative IDs. They do not have a similar representative ID. No similar representative ID is found for a warehouse and for a shop. We know that different representative IDs can be we can found for similar shops for a single shop, and also we can find different representative IDs for a single warehouse. So this is the flowchart they want. From this flowchart, they can know that how we connected shop ID to warehouse ID, and how we get to know that how representative IDs are different for same shops and same warehouses. So from this flowchart, they can easily get our point. How did we get to the report part, and how did we find the sales from for each representative, and they can easily keep track of their sales. In 2.3, they asked us that See the question that the sales data from software is entered manually by salespeople. So there are bound to be mistakes, and there are some mistakes. And they wanted us to know that what quality checks can be performed to rectify them and create a better data, and so that they can keep track of it better in an effective way. In an effective way. Here we can see the mark this table in SOP ID. There is SOP B, SOP -1. These are mistakes, manual errors. These are not bound to happen because we know that SOP IDs are numeric values, and these are mistakes which we have to be rectified. So what can we do so that these mistakes can be rectified? What we can do that we can enter SOP IDs in a digital platform. In a digital platform, we will code it in that way that then we cannot enter any value other than any numeric value in SOP IDs. In that way, it will prevent from these mistakes to happen again and again, and we can keep the data in a more effective way. Similarly, many other quality checks we can also perform different quality checks for to rectify the mistakes and to give a more effective data to the concerned party. Here I have already answered this on encountering an error, what will be your course of action. So when we encounter this error, maybe after also doing our quality checks, still there are some errors. So what we can do is we can call the salesperson who has gone to shop ID who was keeping the data, and we can give them warnings. Not like I'm not saying that we are going to decrease their salary or cut their money. We can give them warnings, and we can give a policy that after 3 warnings, their salary will be reduced. So by that, their efficiency will also increase for the company. So this was my solution for the quality checks to rectify these mistakes. Next, we move on to part three. In part three, this is an additional discussion. First part, we remember that first part was about quantitative analysis. Here we let me go to first part. Here we interpreted the table for warehouse categories, and we also interpreted the graph for sub categories. And we calculated this how many salespeople do we require to allot them to convince them to sell Sinov. And also in part two, it was a qualitative one, but it tested our analytical skills. So how do we find out which shops bought from which warehouses? How do we find the sales from warehouses by using the shop sales values? Then how do we find the sales for each representative? So this tested our analytical skills. In part three, they want to test our logical skills. That how do we encounter a situation? There it is. The question is that consider that a system has been developed to load data and create the performance reports mentioned earlier. We gave them the performance reports, and they use them to use them to load that data. And you have to manage a report where your team delivers these performance reports to sales representatives. So now they have implemented our idea, and they have created these performance reports using the reports we have given in part two. And now they want a project where our team delivers these performance reports to sales representatives. So they are asking 2 questions. What kind of challenges do you anticipate in working on such a project, process-oriented project? So here, what we encounter is when we give this performance reports to salesperson, we can calculate which of them create more losses. Means they fail to convince more shops and more warehouses to sell our products. This way, we can find out which area. I mean, if you see in this table, let's say this repetitive ID is going to soft one, and this soft ID one is located in the area where the average age group is very high, around 60. And we have also been told that Sinov is a product for upper class population. If you remember the given data in the first page, here it was written that it is for upper class population. See, so let's assume that for repetitive ID 1409, SOP ID 7 is located in a poor region, and the maximum people there are not so upper class population. So what happens there is the sales of Sinov is very low. Even if our salesperson goes and convince the shop to sell our product there, the sales is very low, the profit is not so high. So what do we do is from that report, we not only keep track of our salespersons, we also keep track of our profit and losses in the regions. We also think how we can expand our business, how where should we not sell our products. By these methods, we can also know how to improve our business. Also, we know that we can also we normally sell these products in shops. I would suggest that we should sell our brand at shopping malls more, because we already know that we are dealing with upper class population, and we know how upper class population like to buy their products from shopping malls rather than going to different shops for their products, because shopping mall they can get all products in one place, so they would like to go there. So I would suggest them to sell their brand at shopping malls. This can increase the sales, and also last, it will make our brand more popular. So I would suggest this solution. Also for 3.1b, they asked us that what skills would it take to deliver high quality reports on an ongoing basis. Right now I said it that what skills? Normally the skills would be like we should gather information. Information is key. If from these reports we can not only gather information from for sales representatives, we can also gather information about different regions, how the shop is working in that region, if the shop is popular in that region. In one region, there might be case that one shop is very popular in that region, and another shop is not so popular in that region. So it is our loss if we convince this shop to sell our product. So we should also gather information about that region, what kind of people live there. So this should help us to gain more profits. Also, another idea I would give that when our shop representatives reach the warehouses or shops, we should cross check with the shops and warehouse owners that if our representatives are reached on time, they have helped them in organizing the shops, they have helped them in convincing them, they or what is the price that they have negotiated. They should not take any commissions or should not increase our prices to gain their own profits. That will hamper the company. So cross-checking with shop owner and warehouse owner would increase our profits and also increase our brand value. To be fair, so we have given you a solution about a case challenge that would not be we could not get a similar report, similar case challenge from campus beats, but it is very near to similar to towards the case challenge. Only part we have missed is scenario 3. These three parts are a combination of scenario 1 and scenario 2. In scenario 3 we are going to get SQL, and we could not get any GS associates uh, uh, have informed everyone not to share any of their case challenges. So we have shown you a case challenge and given you a solution template so that you can be familiar with any case study in the campus page. Thank you.
So my advice to you all would be that you should not only solve this case challenge in this 48 hours, you should also enjoy it, and because a lot of brainstorming is required to solve this case challenge, so it would be quite a heavy task for you. So enjoy it and try to learn as much as possible from it. Also, I would like to suggest that to have some prerequisite knowledge on ROI, profit and sales, and Microsoft Excel, so that it will be easy for you to solve this case challenge.
Thank you, Abhinash, for coming out for this video. I think this video was quite detailed and quite insightful for the viewers as well. So lastly, I would just like to say that please share this video among your friends, like who are applying, within your teams who are applying for GS. Like this video as well, and do subscribe to my channel. Lastly, have a good day and all the best for GS Case Challenge.